We're in a section where we're talking about electrochemistry. Recall the definition of electrochemistry. It's the study of the relationship between electrical energy and chemical change. Now, we'll be looking at an aspect of electrochemistry, and that is known as electrolysis. Electrolysis is the use of electrical energy to produce chemical change. What we're going to do here is take the electricity and we're going to use it to generate hydrogen and oxygen from water. Remember this? That's right. My 9-volt battery with the platinum electrodes attached to it. What did I use this for? You saw I would invert this in water, and I would form hydrogen and oxygen gas at the different electrodes, right? Well, never did I collect those gases that were being generated. I have with us now an electrolysis apparatus that's equipped for collecting the gases that come off of the electrodes. So what we've got here is the power supply, and I'll turn it on, and electricity will travel through to these electrodes. And look carefully down here, there are these J-shaped electrodes, and I have platinum wire coiled around those electrodes there, and the gases will form and they will bubble up into these inverted test tubes. And what's inside these inverted test tubes is water. And the bubbles will displace the water, you see, and we'll be able to collect the bubbles, the gases. And we find that hydrogen will form at one electrode and the oxygen will form at the other. So let's do this. I'm going to supply the electricity, and there come the bubbles. Watch the bubbles rising up, and they collect at the top. So let's collect this for a while, all right? And see how much we get of each. Let's look at what we have here. Look how much we have in this container. Go over here in that container. Let's stop it for a moment. We've got, what, 5 milliliters of gas here. We've got about 10 milliliters of gas over here. Some bubbles formed. 5 to 10. Ooh, that's a 1 to 2 ratio, or a 2 to 1 ratio. Which test tube contains hydrogen? Which contains oxygen? How do you know? What's the formula for water? Let's collect some more, okay? Aha. So we've collected a lot more of the gases. Let's look at some of their properties. Which one first? That one? Okay. Let me turn off the electricity. We're going to get these test tubes and turn them upside right. But as soon as I lift this out of the water, the gas we've collected can escape into the air. So I'm going to do my best to keep it within the test tube. There we go. By putting this paper card over the mouth of the test tube. There we go. So the gas is in here. And let's look at some of its potential properties. Okay, if it's oxygen, it should support combustion now, shouldn't it? So I have a wood splint. Let's see what happens. See that? Ooh. Evidence suggests that we had collected oxygen gas. You saw how the flame burned brighter because of that gas? What about in here? So it was a 2 to 1 ratio, wasn't it? And we had twice as much volume of hydrogen collected, assuming this is hydrogen, than the oxygen, right? So let's test to see that this is in fact hydrogen. And let's see what happens when I light this. Ooh, combustible. Hey, get that? We did, in fact, form oxygen in one test tube and hydrogen in the other. What happened here? Electrolysis. We used electrical energy to generate a chemical change. We went from water to hydrogen and oxygen gas. Good chemistry to you.